Welcome to lesson 3 in this series. This lesson will see us use some of the things we've done in the last couple of lessons where we set up our database and configured our application to talk to that database and store objects of a given class in the database. In this lesson, we'll actually incorporate those concepts into the Flask handler functions that we've created previously, and so that our Flask application itself will interact with the database rather than us just interacting with the database via the Python shell as we did last time. Okay, so let's see. Previously, we just set up the configuration for our Flask application to connect to our MySQL database, and then we created this DB object, which is an instance of the SQL Alchemy class. And we then set up our task class to extend db.model. That db.model class was part of the SQL Alchemy stuff that we got for free by importing Flask SQL Alchemy. And db.model is a class that we can extend in order to make one of our own classes able to be managed by SQL Alchemy and able to be part of the database. And then we saw SQL Alchemy do the hard work of creating database tables and then ferrying data back and forth between the database and our Python code for us in a way that made sense. So now let's go ahead and use these tools within our application. So let's come down to our handler here, our index handler. We have one view in this application. It's just the one page with the form to add new tasks and then to create new tasks. Let's do the first piece of work, which is to just have our template display tasks actually from the database. So recall last time we actually created some tasks within the Python shell and put those in the database, and so we have those still right here. The first thing to do, let's have this render template pass in those tasks from the database. Okay. So let's see. In order to do that, we saw previously that we could get a list of items from a table, of all items from a table, by saying by using the query object off of the given class. So here I can say tasks equals task.query.all. Okay, we saw that we could use that to query the database for all rows that were in the task table, or in other words, all objects that were of the task class, and that would give us those back to us in a list. So here, now if I define this will use that particular list when I render the template. So let's go ahead and save, and just come back and start up our application and make sure that works. As you're following along, again, make sure you've activated your virtual environment here. Okay, and as always, you can generally ignore these SQL Alchemy warnings for our purposes. And let's come back here and reload this page. Okay, so we noticed that we did get something different rendered in that form, right? Not exactly what we might have expected. Our tasks had the name, these given names here that we saw in the database. That's not what we're seeing right here. And let's understand why that's the case. If we come back to our Flask application, notice that we're passing into the template this list of task objects. Okay, we can confirm from the view here that what is being displayed here are object classes, or task objects rather, because of the way that they are printed out. But they're not displayed in a very user-friendly way. So let's go into the template and see how they're actually rendered in the HTML. Okay, so down below here, where I have the loop that displays each of the tasks, I have a for loop that says for task in tasks, and then it just prints out that given task. Previously, this tasks object was a list of strings. So the for loop would pull out each of those strings one at a time, and then just echo that string into a list item element. Now, though, we have task objects, and those task objects are not just simple strings. They're more complex objects with properties. So rather than just printing out the task object, which is essentially what this does, this just basically calls print or toString, the string method, on a given task object, which is why we saw this sort of output that we're more accustomed to seeing within a Python shell. Instead of just printing out that entire task object, I really just want to grab the name property of it. So if I just say task.name, that should do the trick. Let's come back to our application and refresh. And there we go. So once we make this transition into using persistent objects, we're going to have to be careful about what we're doing within our templates, because those things are going to be objects with properties and additional complex behaviors and methods that we can even call from within our templates. And so far within our templates, we've been doing a lot of just printing out strings. However, going forward, we're going to need to be a little bit more careful about what we're actually printing out within our templates to make sure that they are the actual pieces of data that we want. Okay, so that's one portion of this refactoring. Notice, however, though, when I go to create a new task, when I have a post from the form that creates a new task, I'm still using this old tasks list above. Okay, so let's go ahead and fix that. First, let me just kill this list. We're done with it. We're using a database now. Our application's way cooler, way more sophisticated. Let's kill that dumb list. So here, remind yourself, or let's remind ourselves of what this conditional block was doing. This conditional block says if the incoming request is a post request. In other words, if the request came from submitting this form that is on the page that contained in this template, then we want to grab the data out of that and create a new task. So I still need this line, which pulls the task out of the incoming request. Let me actually change its name a little bit, though, just to be a little bit more clear about what's going on. This will be the name of the task that we're going to create. And then below that, I want to now, instead of putting that into a list, just putting that string into a list, let me delete that line. I want to actually create a new task that's a task object. Okay, and so I can create it by calling the constructor, passing in the name that came in via the form. So now I have this new task object, and just as we saw before in the Python shell, I can put this in the database by saying db.session.add and passing in that object. And then finally, for that to be fully pushed to the database, the db.session.add doesn't actually commit any changes to the database. We need to do that manually by saying db.session.commit. Okay, and so that should work. That should basically replace the old list of strings functionality with this new, much more sophisticated database persistent functionality. Let's go try it out. Okay, so the page renders. That was just the get version of this method, where it just skips over the conditional and renders. Let's try to submit a new task for saving and see what happens when we hit this conditional block. Okay, and that actually seemed to work. We did see this displayed. Let's just do one additional check. Let's go look at the database and see if we see it there. Notice I have to refresh by basically clicking on the Browse tab again to get that data pulled. And we see now we have a third task in our database. One thing that I want to point out that I didn't point out in the last lesson is notice that the ID columns, or the ID column is populated for each of these rows, right? 1, 2, 3. Now we set up, in our code, we set up the ID property of the task class to be an integer column. And also to be a primary key. However, nowhere in the code, either in the last lesson or in this one, have I actually set the ID of a given object. That happens when I commit it to the database. Flask SQL Alchemy will do the work of recognizing that a given object should have an ID because it's a primary key, and it will generate that ID to be unique for me, so I don't have to worry about trying to determine, to make sure that I set an integer and to make sure that integer is unique amongst all the classes. I don't need to worry about that. That's going to be handled for me, and so I'll get this behavior of having unique IDs auto-generated that I can use whenever I want. Okay, now let's go ahead and add some additional functionality, which is to be able to delete tasks from our database or from our list. And we're going to kind of do this in a sort of naive way first, and then in a better way in the next lesson. Okay. In order to delete these tasks, I'm going to need to modify the view to have some additional behavior. So down here where I'm displaying the task, I basically, within each LI, I basically want to put a little button that a user can click on that will allow a task to be deleted. So let's go down here and hit enter. Within the LI tag, each task will have its own little form. And that form will post data. And its action is, we haven't created it yet, but we'll call it /delete task. And basically what this form is going to be is a button. That's all it's going to be. Well, one little piece beyond the button, but let's put it in the button first. So I'll put an input of type equals submit. And I'll set that its value. Recall that the value of a submit button is the text that's displayed. And I'll make it something kind of specific to the context we're working with. When we're completing a task, we're basically marking that task as done. So I can say value equals done. One more additional thing that I want to do here is to put a hidden input. I don't want the user to see this. I'm going to put a hidden input that holds the ID of the given task. So I'm going to make an input type equals hidden. The name is going to be task-id because that's actually what's going to be the value. It's going to be the ID of the given task. So the way I can do that is, again, by using these Jinja expression tags, the double curly braces, and I can say task.id. So again, we saw that each task object that comes out of the database has an ID property that was populated by an auto-generated value for us. We can use that within our applications as well. So now each task item within our list will have its own little form. Basically, by clicking on the button that's next to the task, that will make a post request to the server to do that. And again, the difference between a get and a post here is crucial. We wouldn't want to submit this form via get because we're changing data on the server. Recall that one of the use cases where you always want to use a post request is when you're changing data on the server. Okay, let's go back to our application and refresh and see what happened. Okay, I don't actually want to refresh since the last request I made was post. So let me go to the address bar and hit enter to submit a get request to refresh the page. Okay, so now each task has a button next to it. And if we were to inspect this, let me pull open the browser tools. If I were to inspect that, I would see that button is part of a form. And the only visible piece of that form is the button, but there's also a hidden input which contains the value of each task. So I have value equals 1 for my first task, value equals 2 for my second, and so on. Okay, one thing I want to do here is just clean this up a little bit. I want this button to be displayed over to the right of each item. So let me come over and just add an inline style here. I'll say that the form has style equals, and then I'll give it display inline block. Inline block, if you haven't encountered that, basically says that the item from the external perspective, from the elements that are surrounding it, should appear to be inline, but in terms of the elements that are inside of it, should appear to be a block element. So let's do that. And yeah, there we go. So inline block is a useful way to take elements that are normally block level elements that you want to be displayed inline and make them be displayed as such. So now I have 3 tasks, each with a done button. So we have a form now. Now if I click on this form, nothing's going to happen. In fact, I'll get an error. I'll get a 404. That's because this path is not configured in my Flask application. Let's go do that first. Okay, so come back to main.py, and let me just copy this to make sure I don't make a typo. We want to add a new request handler. And it should handle requests at its delete task, and it should only handle post requests. And let's call it just delete task. Okay. And what we want to do with this task, with this handler, is to take the given ID that's posted. Recall that this will be reached by virtue of submitting one of these forms that the user will submit by clicking on the button next to each task. And the only piece of data that's going to be in there is something with name equals task ID. So we want to grab that task ID, and we'll be able to use that task ID to delete the task from the database. So let's get that. And recall that in order to get a piece of data out of a post request, we say request.form, and then the name of the data that was submitted. So that will give us the task ID. We want this to be an integer, though. The task ID property of a task object is an integer. So let's cast this to an integer. Okay. Now, in order to delete this task with this ID, I need to get the actual task object from the database. So let me just do that by saying task equals, and here we're going to introduce the first of a couple of new SQL Alchemy or Flask SQL Alchemy commands that you can use. This one, we can say task.query.get and pass it the task ID. So what happens here is if we've seen task.query.all previously right here, and that pulled all of the task objects out of the database. Here we want to get the specific task object with the specific ID that we're passing in. So we can use the get method of query to do that. So task.query.get, and then we pass in the numeric ID of that given task that will give us the task object that we're asking for. And then I can say db.session.delete and ask it to delete that task. And as with all database session stuff in Flask, I need to commit that. Okay, and so that will basically flag that object for deletion. The commit actually goes to the database and runs the corresponding query to formally delete it. So let's go back and make sure that our server is still running. It appears to be so. And I'll come back and refresh my page. And let's just try this out. So when I click on this button, what should happen is that I should see a request sent to the server and then that object being deleted from the database. Although, you know what? Something I just recalled that we forgot to do is I'm not returning any content from that request. I need to actually just return the user somewhere after they ask for us to delete a task, right? Let's go ahead and just redirect them back to the main page. Okay, since that's the only actual view we have within our application, let's just redirect them there. Okay, so let's go ahead and I'm going to open up my developer tools and go to the network tab so we can kind of see what happens when I hit this button. I'm going to just delete this last one we added. Okay, so visually it appears that happened. Let's see what actually happened when I did that by inspecting the different requests that occurred here. The first request is the request to the /delete task path. If I click on that, I see that that was made to localhost :5000 /delete task. And if I look at the params, I see that the post request sent the task ID parameter with the value 3 to the server. Note, see that value is represented as a string. That's the way it's going to be seen when I pull it out of the request in the Flask application. And that's hence why I had to convert it to an integer right there. So this little piece of data was submitted to this handler function. I then pulled that piece of data and converted it to an integer. I then asked for that task object with that ID from the database and then told the database that I wanted to delete it. And then I returned a redirect. And so notice that this first request to delete task responded with a 302, which basically said that it should redirect. And that resulted in us redirecting to the root path, which was the second request that returned a 200 status code. And that's what we actually see on the screen. That second request, since it came after the deletion of the task in the first request, rendered the view with only the 2 tasks that are remaining in the database. Let's go ahead and look at the database and see if that task disappears. And indeed, it does disappear. Okay, so and thanks for watching this lesson. Just to summarize what we did here, we modified or refactored our index function to use our persistent task class when we create a task and when we render our list of tasks. And then we added a form and a handler here that can handle a post request from that form that can delete a given task from our task lists. So now we can check things off. In the next lesson, we're going to see a little bit better way to handle deletion of tasks and to extend or improve our persistent objects.